All right, welcome to Geometry 3.2.3, sorry about that. And what we're learning here now is a bunch of converse theorems. So we're learning the first one here is the converse of the corresponding angles theorem. You remember the corresponding angles theorem was if you're given two parallel lines, then their corresponding angles, this is one set of corresponding angles, there's more, there would be this angle and this angle, or this angle and this angle, right? Given if these two lines are parallel, their corresponding angles will also be congruent. The converse is also true. And so the converse says if angle 2 is congruent to angle 6, then you could say line L is parallel to line M. And this is the notation to say line L is parallel to line M. So that's that notation there. This is going to be the kind of the groundwork when we get into proofs of these other theorems. This is what we need to prove. Again, if we could prove, and I'm going to label some other corresponding angles here. So if we could prove that this angle and these angle have the same measure, or through reasoning, then we could say line L and line M are parallel. Or if we found, I'll use a different color here. If we found this angle and this angle, again, another pair of corresponding angles. If we could show that the corresponding angles are equal to each other, or congruent to each other, then we could prove that their lines are parallel. Let's look at the next one. This is where we're looking at alternating interior angles. And if you remember that one, this theorem stated that, again, if you're given parallel lines, such as L and M here, their alternating interior angles will be congruent. The converse is also true. So if angle 4 is congruent to angle 6, then line L is parallel to line M. It's that simple. So if you were given lines and you could, this said this is, 59 degrees, and it said this is 59 degrees, then you could say that line L and line M are parallel. For a third one, we have the same side interior angles postulate. So if you remember this one, what this said was if you're given parallel lines, that their same side interior angles will be supplementary. So that means we could say the converse is true. So if angle 3 and you add it to angle 6, if the sum of that equals 180 degrees, then you could again say line L is parallel to line M. So if you had, if this was 80 degrees and this was 100 degrees, then you could say line L is parallel to line M. The converse of alternating exterior angles. So real similar again, but as alternating exterior angle theorem said if you're given two parallel lines, that their alternating exterior angles, so in this case 1 and 7, are congruent to each other. And same thing here. The converse says if angle 1 is congruent to angle 7, then line L is parallel to line M. So again, if these had the same degrees, if this was 110 degrees and this was 110 degrees, then you could say line L is parallel to line M. Let's look into a proof. So you're going to have questions where you have to prove some of these theorems you went over. So this one's saying prove the converse of the alternate exterior angle theorem, so the one that we just looked at there. And to do this, what we need to say again, if you remember, is we need to find a pair of corresponding from the very first thing we looked at. If we could find a pair of corresponding, so if I could show that angle 1 and angle 6 are congruent, this corresponding pair, then I could prove that angle L and M are parallel. If I could show that angle, not angle 1 and 6. If I could show angle 1 and 5, this is a corresponding pair. If I could show that these two things have the same measurement, then I could prove that L and M are equal to each other. Or if I did 3 and 7, if I had 3 and 7, that's another corresponding pair there. If those are congruent, then I've proved L and M are parallel. So let's just write a little flow proof to get this going. So let me change my color here. So what we're given to start off with is we know that angle 1 is congruent to angle 7. And this is just from in the problem. This is given to us. So we're given that. We also know that angle 3 and 1 are congruent. How do we know that? Because angle 3 let me change back this color. Angle 3 is a vertical angle, right? So angle 1 and 3 are congruent because this is because of vertical angles. Vertical angles. Theorem. Vertical angles are congruent. Now we have our set. I'm going to try to highlight this with even another color. We have our set. We have angle 3 and angle 7. And let's look what we could do here. These two, if we use the transitive property of congruence, I can see that angle 1 are set equal to each other here. So that means angle 3 and angle 7 are equal to each other. Angle 3 and angle 7. Again, this is just the transitive property. So, since these are equal, we're going to say angle 3 and angle 7. Are congruent to each other. So since this is true, then again, that rule was what we needed was, to say if we could find two corresponding angles that are congruent to each other, then the lines are parallel to each other. And we've done that. We've shown that since angle 3 and 7 are a corresponding pair, therefore the lines L and M are parallel. All right. Hope this helped. Again, when you're working in the book, you want to get to this point. Can you somehow show that a pair of corresponding angles are congruent to each other? And if you did, therefore you've shown that their lines are parallel. In order to get this, you might need to use a reason like that vertical angles are congruent. But again, you're trying to get to this idea of if you can get corresponding angles, then you can show that their lines are parallel. Good luck.
Made with Doodlecast Pro.